Okay, uh, this is the this is the term two, week three, physics CA. I know it's early, بس يعني some people they like to study the physics CA, the AMS quiz instead of the periodic. فأما just put it because يعني it's easy صراحة. It won't really take much time. مهم, they give you weights. It's a box. Give you angle 30, but they say that the box moves with a constant speed. Okay, before anything, know that if there's a constant speed, معناتها acceleration is zero and the net force is zero if it's a constant speed. Okay, always know that. And that means it's Newton's third law. uh, the law of inertia is that if the forces are balanced, then the acceleration will be zero. Okay, and well, not the acceleration. If the forces are balanced, then it's gonna be uniform motion. Yani it won't speed up or slow down. It's gonna stay at the same speed. Okay, and since it's moving with a constant speed here, that means, yeah, sorry, if the forces are balanced, then the acceleration is zero. So here, since there's a constant speed, معناتها the forces are balanced. معناتها the acceleration is always zero, and the box is said to be in equilibrium. Equilibrium معناتها it's not moving, means it's equal here and here, and the behavior of the box is predicted by the principle of inertia. Inertia says, you know, if there's balanced forces, the objects will not speed up or slow down or stop or start moving. Okay, that's easy. G, the gravitational acceleration. Just memorize it. Know that it decreases as altitude increases, and it's constant for the first few hundred meters above sea level. Just memorizing. Uh, if a body is free falling, then the acceleration is constant. Okay. W equals mg, and this one, if g is 9.8, what's the weight? If it's 5 times g, which is 5 times 9.8, which is 49. Force equals mass times acceleration. Uh, okay, yeah, this one is a bit different. If the distance, there's gravitation force between them. If the distance becomes doubled 2d, then what will the force be? And I told you, since the distance is in the denominator, it's 1 over 2, and you always square it. Okay, so you always square it. Always square the distance, because it's, remember, it's force equals g m1 m2 over r squared. So you always square this r. Okay, so it's 2 squared, so 1 over 4, which is 0.25. Okay, always square the distance. This is simple. يعني m plus m plus m is 3m. That's it. How many minutes are we on? 3 minutes. Okay. The net force acting on an object divided by the acceleration. So what is F divided by A? Obviously m, which is mass. A bucket of mass 2 kilograms is being lifted. It accelerates at 1 meters per second squared. Use g as 10. Okay, what is the weight? Weight is W equals mg. W equals the mass, which is 2 times the gravity, which is 10, which is 20. The tension. Always note that the tension, it's carrying both the weight and the drag force. I explained this in the course practice recording. The, the tension will always be dragging the box up, right? But what will it be dragging? It will have to drag the tension and the weight. Okay, sorry, it will have to drag the drag force and the weight. If we said the weight is 20, we still have to find out the drag force. And the drag force is F equals ma. So F equals 2 times 1, so 2 newtons. So عندك 20 نيوتنز وعندك 2 نيوتنز فبيصيروا 22 نيوتنز. Okay. Uh, Question 10. Uh, Again, a block of mass 1 kilogram is pulled around a smooth 1 kilogram is pulled along a smooth horizontal surface using a rope. The rope makes an angle of 30 degrees. The tension is 10, whatever. Use g equals 10 sine 30, whatever. Okay. The horizontal acceleration. Okay. Since we're looking at the rope making an angle of 30 degrees, since it's an angled force, we're always going to have a horizontal force and a vertical force, right? The horizontal force, in this case, they're saying they're calling it horizontal acceleration. Okay, the horizontal acceleration, you understand that acceleration uh, is F equals ma, so the acceleration is F over m, because you take mass to the other side. Okay, so in order to find the acceleration, we need the force. Okay, and let's find the force. In this case, we're talking about the horizontal acceleration, for that means we need the horizontal force. How do we find the horizontal force, Fx? It's always the force times cosine of the angle. So in this case, it's Fx, it's the force, which is 10, times cosine 30, so 10 times 0.87, which is 8.7 newtons. Okay, so now let's go back here and we can plug in our force as 8.7 divided by the mass, which is 1, and you get 8.7 meters per second squared. The weight of the block, weight is W equals mg, for weight is mass, which is 1, times g, which is 10. Uh, so you get 10 newtons. And the normal reaction on the block, the normal reaction is always the vertical force. How do you find the vertical force? Any Fy is the force times sine of the angle. So Fy equals the force, which is 10 newtons, times sine of the angle 30. And you get that 10 times sine 30 is 0.5, so you get 5 newtons. The distance between the Earth and the Sun is 1.48 times 10 to the power 11 meters. Uh, the mass of the Earth is 5.97 times 10 to the power 24 kilos, and the mass of the Sun is 1.99 times 10 to the power 30. UG is 6.67 times 10 to the power negative 11. What is the gravitational attraction? Okay, gravitational attraction, هي دايما the formula force equals G times M1 times M2, sorry, M2, okay, over R squared. Okay, تذكروا that G is the constant given, M1 is the mass of the first, mass of the second is M2, and R squared is distance squared. Type G is 6.67 times 10 to the negative 11 times mass 1, which is the mass of Earth, which is 5.97 times 10 to the power 24, times the second mass, which is 1.99 times 10 to the 30, divided by R squared, so the distance squared, so 1.48 times 10 to the power 11 squared. Okay, you do this in a calculator and you should get 3.6 something times 10 to the power 22, like here. Then part B, the acceleration. I told you acceleration, it has a formula. G equals big G times the bigger mass, it's the bigger mass, okay, over, again, R squared. Okay, uh, so G in this case equals the gravitation big G, the constant, which is given 6.67 times 10 to the negative 11, times the bigger mass, which in this case is the sun, so 1.99 times 10 to the 30 over R squared, يعني 1.48 times 10 to the 11 squared. You do this and you get 6.06 times 10 to the negative 3. Okay, the International Space Station is orbiting the Earth, okay, at a height of 408 kilometers above the surface. Mass of Earth is 5.97 times 10 to the 24, and the radius of Earth is 6371 kilometers, and the big G is 6.67 times 10 to the negative 11. Okay, the force that keeps the ISS in weight and so in orbit is obviously the weight, because you're in space. You need something that will keep you close to Earth, and that will be your weight. Okay, uh, part B, the acceleration. So it's gonna be G equals GM over R squared. Okay, but make sure, okay, like I said in the other recording, that your distance is in meters. Okay, if it's not, then I'll show you what to do. But let's first substitute. G is 6.67 times 10 to the negative 11. The mass of Earth is 5.97 times 10 to the 24 over R squared, يعني the distance squared. But you have to find the total distance, yeah? Because you have the planet Earth, you have up the radius, which is 6371, And then you have again above it, they said 408 kilometers. If you add these, you get 6779 kilometers. طب okay, what you have to do is, since we're talking about squared, you have to put this squared, obviously r squared, yeah, and then you have to multiply in the denominator by 10 power 6. So you have to like divide by 10 power 6 at the end. I know when I'm putting times 10 to the power 6 directly, it's putting for me the calculator error. Okay, so I suggest you just solve it without the 10 power 6, and then after that do the answer divided by 10 to the power 6. Okay, and you should get 8.67 meters per second squared. Okay, another thing, the mass is this. What is going to be the weight? Weight is mg, يعني 4.2 times 10 to the 5 times g, which is we found 8.67, and you get 3.64 times 10 to the power 6. How question 14? Oh, okay. For every two particles in the universe attract each other with a force that is directly proportional to the product of the masses, because remember m1, m2, and then inversely proportional to the square of the distance between them. Remember m1, m2, g m1, m2 over r squared, so the square of the distance between them. Okay, and the last one, yeah, if the distance r is doubled, remember distance is the denominator and you square it, so 1 over double يعني 2 squared, so 1 over 4 يعني 0.25, which is a quarter. Both masses are doubled, so m1 got times 2 and m2 got times 2, so times 2 times 2 equals times 4, so quadruple. Both masses are doubled and the distance is doubled, so times 2 times 2, okay, in the numerator, and the distance يعني times 2, sorry, times 2 squared, so times 2 times 2 is times 4, times 2 squared is times 4, so you get cancel, you get 1 over 1, so it's unchanged, it doesn't change.